These polynomials should be a little bit familiar to you since we covered them basically the entire third quarter. We're going to add, subtract them, we're going to multiply them, and we're going to use the synthetic division. I didn't see any long division on the test. If there happens to be a long division question, it'll probably just be one question on the test, which if you forget how to do long division, that one question probably wouldn't be worth it because it takes a long time to go over. But I noticed a lot of synthetic division, so we'll make sure we cover that because it's an easy little thing to do. It doesn't take long, and much easier to learn than synthetic division. But we'll start with adding and subtracting. So just like the complex numbers video and stuff, we are just combining like terms when it comes to adding and subtracting. The exact same thing. So if you got the complex numbers one already done, this should be just as easy, I would hope. Make sure we're ready. Okay. So for the examples, we're adding two polynomials, so that just means find your like terms and combine them. 3x to the third and 1x to the third would be 4x to the third, right? Because 3 and 1 make 4. You don't change the exponents, you just simply combine the terms together, add the coefficients up, but don't change the exponents. So then your x squared is negative 5x squared and negative 2x squared. Negative 5 minus 2 would be negative 7x squared. You'll notice the x term, there's only one x term. It doesn't have a partner, so we just kind of bring it down, negative 2x. And then the 7 and 5. So positive 7 and a positive 5 would make a positive 12. Right? And that's all there is. For the other example, which is subtracting, do what you did with the complex numbers. And that is kind of distribute the negative. Go ahead and change the sign on all three of these. So make this a negative x squared rather than a positive 1. Make that a negative 3x, and then make that a positive 1. And then it's pretty much the same exact thing as before. You just combine your like terms. So 3x squared minus x squared. So it's 3 minus 1, which would be 2x squared. Your x terms, 4x minus 3x would be 1x. So it's just plus x. And then negative 5 plus 1 would be negative 4. Okay? So that's all there is. Just kind of remember to change those signs. It helps that way. Also, again, similar to complex numbers, try to do these without a calculator. Try adding these integers up without a calculator and get used to that because you do have non-calculator questions on your test, and this might be one of them. Okay? So pretty much all these are the exact same thing. Just find your like terms and add them or subtract them. But remember, like for instance, number 4, 5, and 6, change the signs would help you the most. So make the negative 6x to the 5th plus 5x to the 3rd and then minus 3. Because distributing that negative, all it's going to do is change those signs. Doing that helps clear up a little confusion. Okay? So let's go to multiplying. I'll leave my example alone. I'll go ahead and do one of yours. Let's see. I'll do number 8. All right. So number 8, multiplying. Now, I like to use a table. You don't necessarily have to, but I do it because it keeps me from making any mistakes. It keeps me organized. It's just helpful in that sense. So to make a table for number 8, it doesn't matter which goes on top and which one goes on the side, but I'll just put it as 4x squared, and then a negative 3x, and then a negative 2. Right? And then on the side, I'll put the x squared and then the 5. All right. So I'm kind of OCD about my lines, so I'm going to fix that a little bit. Make it look real nice, you know what I'm saying? All right. Anyway, now you're just multiplying and filling in the boxes. I'm going to use a different color here. So the first box, 4x squared times x squared. This would be 4x to the 4th. Now, unlike adding and subtracting, when you multiply these, you actually combine the exponents. Now, combining them, I mean add the exponents together. All right, so 2x's and 2x's would make 4 of them, so that's why it's x to the 4th power. The box right below it would be 4x squared times 5. Now, 4 times 5 is 20. And I still have x squared. There's no x's with 5, so I didn't have to add any more to that x squared. All right, the next box, negative 3x times x squared. This would be negative 3x to the 3rd. And that's because x squared combined with an additional x adds up to 3x's in total, so that's why it's x to the third. Negative 3x times 5 would be negative 15x. And the last column, so negative 2 times x squared would be negative 2x squared. And negative 2 times 5 would be negative 10. All right, again, be careful with these. Make sure you don't mess up a negative, because if you forget, a lot of people do that. A lot of people forget to include these negatives. Obviously, you're going to be completely wrong when you try to combine no like terms. So make sure you pay attention to the negatives. I think that's part that most people would make mistakes with. But now we're not done. We just did the multiplying. Now we need to combine the like terms. So look for like terms. So we'll start with the x to the fourth term. There's no other x to the fourth term, so we're going to just bring it down. Then your x to the third terms. Again, this is the only x to the third term, so we'll just bring it down. There are, however, multiple x squared terms, right? There's, let me kind of circle them in a special color. Negative 2x squared and 20x squared. We can combine them. So 20 minus 2 would be 18. So that would be 18x squared. And then negative 15x is all on its own because there's no other like terms, and negative 10 is all on its own. So a lot of that we just kind of brought down. But then some of the other ones, like 7 and 9, I know you have to really find, there's several more like terms that you have to combine. Okay? Look for them, add them up. Don't change the exponent at that point, and you'll be good to go. All right. Now the last thing to cover is our remainder theorem. This is the synthetic division. Now all of these are going to use synthetic division, but it sometimes asks a different question. So if it's asking what is the remainder, then just use your synthetic division to find the remainder. So our synthetic division is where we have our little a value in the box, the coefficients next to it, and a little line under. Anyway, so our a value comes from this, and it's always opposite of that. So it's minus 4. So in this case, it's going to be positive 4 in the box over here. And the numbers that go next to this are the coefficients of these terms. So you'll see 1 for 1x to the third, negative 5 for negative 5x squared, 2 for 2x, and then 5 for 5, obviously. All right, make sure there's a little bit of space here because you are going to write some numbers below them, and then you'll have some numbers below the line as well. All right, but anyway, so that's the setup. Everything's set up properly now. This is all the math that's required. So the 1, you just bring it down, doesn't ever change. Everything that goes below this line, you're going to multiply with that a value, which is 4. So 1 times 4 is 4. And that answer is going to go in the next spot over. Okay. Now we're going to add these, negative 5 and 4, to get the next value below the line. So negative 5 plus 4 would be negative 1. And now I'm going to take the negative 1 and multiply it with the a value 4. Okay. So negative 1 times 4 is negative 4. I'm going to go to the next spot over, and then you add them again. It's basically subtracting because it's 2 minus 4, which would be negative 2. Negative 2 times the a value 4 is negative 8. And add 5 minus 8. So 5 minus 8 is negative 30. All right, now I've got my remainder. My remainder is negative 3. It's always his last digit over. So our remainder is a negative 3. Chances are, if this is a test and I want you to type it in, all you're going to do is just type in negative 3. You don't have to write us a full sentence. Again, these tests are being graded by idiots, so don't overcomplicate things. Just say negative 3 is good enough. All right, now the second type of question is x plus 2 a factor of that. You're going to do the exact same process. Nothing's going to be different. You're going to still keep this as the opposite sign. So it's going to be a negative 2 rather than a positive 2 in the box. That's my a value. You still have the coefficients, so 1 for 1x to the third, 1 for 1x squared, 1 for 1x, and then 6. So again, that's 1, 1, 1, and 6. All right? Leave a little space, draw a line, and then do the same exact thing. Okay? Now the difference between this one and the last one is, last one just wanted to know what the remainder was. This one is, if the remainder is 0, it is a factor. If the remainder is anything other than 0, it is not. So let's start. Let's bring the first term down. Bring the 1 down. Doesn't change. Multiply this to a. 1 times negative 2 is negative 2. All right, add them up. 1 minus 2 is negative 1. Then multiply negative 1 times the a value, -2. So -1 times -2 would be +2. Now add those up. 1 plus 2 would be 3. And then 3 times -2 again. 3 times -2 is -6. And 6 minus 6 is 0. So for this example, it's yes, it is a factor. Okay, and the reason is because our remainder equals 0. Okay, I know there was a question exactly like that on the practice test. So all of these are going to do the exact same thing. They're all using the same method. You're changing the sign on all of these. Now, there's one type of question I didn't put on here, and I didn't put it on here because it wasn't on the practice test, but just in case you're still watching this and you want to know, because there was a time when we did not change the sign. You know, on all of these, we changed the sign here. Obviously, on that problem, it would be we would change it to -3 and work that out. The only time you don't change it is if it asks, and the reason I don't think you would have to do this is because you can just use your calculator instead, is if it's asking, you know, let's say you have the same question here. You don't have this part, you have the polynomials of it, but it asks you, what is p of 3, right? In that case, you would use 3 in the box, not -3, okay? If it asks something like that, if it asks p of 3, or say it says x is 3, you know, then you don't change the sign. But if it's like every other problem where it gives you a binomial, like x plus 3 in this case, or anything like that, then you do change the sign. Okay? If it explicitly says p of a number or x equals that number, you don't. But I don't think that's going to show up, which is why I gave you all of these. Okay? I think that'll end it for this video, guys. It's pretty much all there is to know. Everything's pretty much the same as the one I worked out. So I'll see you in the next one. Later.